This is CS2316 final presentation. We are trying to understand the relationship between the unemployment rate, interest rate, and the housing sales in the state of Connecticut.
Coming to objectives, we wanted to explore the relationship between interest rates, unemployment rates, and housing prices in Connecticut, and then determine which property types are most volatile by using metrics like elasticity and correlations. Some of our expectations, we hypothesized a clear negative correlation between interest rates and housing sale amount, and the same for unemployment rates as well. We chose this topic since we've always been interested in economics and finance and wanted to test the theory that we learned in class. Inspired by the film Big Short on the housing crisis of 2008, we added the aspect of recessions and how they affect the housing market as well.
For the data collection, we found the CSV dataset from data.gov and the size was 125 MB. We basically tried to collect the housing sales data for the state of Connecticut, and we focus on the sales value, property type, and sale ratio. Secondly, the JSON dataset was also from data.gov and the size was 1.2 MB, and we collected the monthly interest rate of years over a period of 20 years. Our focus areas were monthly interest rate, security bonds, and years. Finally, we found the HTML dataset from cd.gov, which is the official CT government website for datasets, and calculated the unemployment rate for CT, and we focused on the unemployment rate on a monthly basis. For the CSV cleaning, I used the modules of pandas and numpys. The first thing we did was we dropped columns we did not need for efficiency as well as reducing carbon emissions. The first inconsistency we focused on was we changed the date format to make it year only so that it is consistent with other data sets, and as you wanted to find the correlation later as shown here. Also, secondly, we converted all the zero values to NaN values, because when we are calculating the mean, we are getting a skewed mean due to the outliers, and hence we use the dot replace method in order to make sure that the zero values are ignored while calculation mean. Finally, used group by to group by using the residential type and the year recorded, and found the average sales amount, and also did the same for the year recorded and find the average sales amount, and the output is shown on right.
For HTML cleaning, I use the modules Beautiful Soup, Pandas, and Requests. First, I use the request module to get the HTML code from the website. Then I use Beautiful Soup to pass through the data and extract the text into a list. And then I created a data frame using the list, addressing the inconsistency 3. So the last 3 values for the year 2024 were empty in the table, so they were giving random values. So I changed them to np.nan and then I calculated the mean for each year using the inbuilt function .mean. Then I filtered the values to only consider the time frame that I wanted, which is from 2001 to 2024. And then finally, some extra cleaning. Since we only wanted the average unemployment rate per year, I used the transpose functions and some extra operations to get the desired form on the left. Coming to JSON cleaning, for this I use the modules pandas and JSON. First, I use the JSON module and JSON.load to read the JSON file into a Python dictionary, and then I use it to create a pandas data frame where I only consider the rows where the security description was either treasury bonds or treasury inflation index bonds. Inconsistency 4, in a few rows the values for average interest rate amount was the string null, which would have hindered the calculations for the mean. So we replaced them with np.nan, so it automatically skips them during mean calculations. Finally, I use group by to group the data and get average interest rate by year and rename the column for simplicity. The final output is shown on the left.
Sustainability was a big focus for our code, and we wanted to make sure that we only write efficient code so that we reduce our carbon emissions. I think the first step we took towards that was to measuring the carbon emissions, and the CSV dataset, which was a file of 125 MB, took around 6 to the power 10 is to minus 6 emissions, whereas the HTML took like 1.55 and JSON took 2.85, which was a much smaller amount. So I think one of the main insights that we both got out of this was that as the dataset increases, the size increases, there are more operations and more computations, which increases the carbon emissions. And thus, I think we made a rule of thumb that we would not do any unnecessary iterations, and also we have dropped a lot of columns, especially in the CSV files, so that we don't have to go through calculations of each one of them, and we can reduce the carbon emissions. And hence, we wanted to make sure we have the most efficient and optimized code.
For Insight 1, we wanted to compare the relationship between interest rates and average housing sale amounts and the unemployment rates, and determine whether unemployment rates or interest rates has a greater effect over housing sale values. To calculate the correlation values, we use the pandas built-in function .core. We hypothesized that an increase in interest rates would lead to a fall in average housing sale amount, and the same for unemployment rate. For the visualizations, we use plotly.graph objects in go.scatter and go.bar. Visualization 5 and calculated correlation minus 0.493 indicates a strong negative relationship between interest rates and sale amount, supporting our hypothesis. However, visualization 2 and the very small correlation value of minus 0.0559 suggests a very weak correlation between unemployment rates and sale amount. This does not fully support our hypothesis. In conclusion, we have determined that the interest rates are more likely to affect housing sale prices than unemployment rates. For Insight 2 and Visualization 3, we wanted to see how the housing market composition has evolved between the years 2008, which was a housing crash year, and 2023. For this, we chose the pie chart, which we created using Plotly.Express. We initially hypothesized that the percentage of condo and four-family sales should remain somewhat same, since both of them are luxury segments, and that single family would be lower in 2008 due to recession than 2023. From the figure in the data we calculated, we can see that the percentage for condos have remained similar from 19.4 to 18.7, highlighting its resilience to economic conditions. However, we saw a rise in four-family sales from 17.2 to 19.5, suggesting a rise in demand for these homes. The figure also suggests that the percentage of single-family homes actually decreased from 13.8 to 28.2, suggesting that they're losing their market share.
For Insight 3, we wanted to understand that commercial properties versus residential properties, out of them which are more volatile to unemployment, and hence for this I tried to calculate the elasticity. Elasticity was basically the change in housing sales by change in unemployment rate. So I tried to find the change by using the dot shift method, which helped us to find the last value. Also, it is important to note that the first row did not have a previous value, and hence is a NaN value, as you can see here. I just found the change in unemployment rate divided by change in sales amount, and just found the ratio to find the elasticity for both of them, and the output is shown on the right. Continuing on Insight 3, here are the two visualizations that we created, and we just used the add trace method to do both of them. And the main insight that we got was that mean elasticity of condos were around 18,000, whereas the mean elasticity of single family was around 27,000. And hence we concluded that for 1% increase in unemployment, there will be a decrease of sales amount of around 27,000 in single family as compared to 18,000 in condos. This showcases that single families are much more volatile, and it is due to the fact that during unemployment, there might be financial burdens and commitments which will be more important compared to buying a new house.
For Insight 4 and Visualization 4, we wanted to see whether the housing market reacts the same way to different recessions, 2007 to 2009 and 2019 to 2021. For Visualization 2, I used Plotly.Express and a bar chart to show the trend of average housing sale amounts over time. And for the insight calculation, I used built-in functions like .pcd change and .def. We hypothesized that during these periods, we would see a consistent fall in demand and therefore fall in real estate sale amounts. From Visualization 3 and the calculated data, we can see the hypothesized downward trend between 2007 and 2009, with the average sale amount falling by 14.2% on the first year and 21.4% the second year. Overall, a decrease of 32.7%. However, for the COVID-19 recession, instead of falling, the average sale amount shot up by 9.9% the first year and an overwhelming 43.5% the second year, which is surprising as it goes against the theory and the hypothesis. Therefore, we saw that different recessions can have significantly different and opposite effects on the housing market.
For Insight 5, we wanted to understand the relationship between the housing sale amount and interest rate in terms of affordability, that how has the affordability changed since on 1 to 2023. So for this, we just try to calculate the price to rate ratio, which was basically the housing price divided by the interest rate. Also, we try to normalize this by dividing each of them by the year of 2001 interest rate, and this was something new which we had to learn because I had never took like a stats class before. For the insights, we found that the normalized price to rate ratio has been increasing steadily, whereas the interest rate has been going down, leading to a disconnect there, and hence we concluded that the affordability of the houses has worsened due to the overvalued high housing prices along with the disconnect which was found in the previous part. In terms of challenges, it was difficult to find ways to get two y-axes on the same plot because we did not know the add trace method, and we had to look through a lot of documentation to find that. I think we concluded that housing sales has a very strong negative correlation with interest rate but a very weak correlation with unemployment rate, and also the residential housing types are more volatile to macro conditions compared to the housing commercial sites. In terms of next step, we would also like to look at other indicators such as economic growth, and also make our research much more broader and look at different states and not only in Connecticut in order to understand the relation. Thank you.